The most obvious way to detect an extrasolar planet is direct, by imaging. However, some simple numbers show that this is a very difficult experiment. As seen from afar, Jupiter reflects some of the Sun's light, but it's very little, only 2/100000ths. You can work this out from the inverse square law and the size of Jupiter relative to its distance from the Sun. It's actually worse than that because we only see half of the reflected light. Think of the phases of Venus. And Jupiter is not a perfect mirror, reflecting only 30% of the photons that fall on it. So the total fraction of light reflected by Jupiter from the Sun is 3 × 10⁻⁻10, a very small fraction. What about a smaller planet? For the Earth, the situation is actually worse. Although Earth is 5 times closer to the Sun than Jupiter and intercepts 25 times more light from the inverse square law, it's 10 times smaller, and so its cross-sectional area is 100 times less. The product of those two means a 4 times more difficult experiment. Also, as seen from afar at the distance of a nearby star, the angular separation of the Sun and Jupiter is only a couple of arcseconds, and the angular separation of the Sun and the Earth would be less than an arcsecond. Thus, it's like trying to see a candle flame in close proximity to a football stadium arc light, an extremely difficult experiment that has not yet succeeded.